Hello, let's do the New York Times Hard Sudoku for September 4th, 2024. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, how do we want to get started? How about let's do our normal scanning. This is pretty, there's a lot of givens in this band, so we'll have to scan carefully. So we've got 2, 6, and 9 here. So I've got these two 2s here. That puts a 2 in one of these two. We have all of our 6s. These two 9s. Place a 9 here. All right. Also want to look at the 5 and the 6. We already looked at 2 and 9, right? So the 5, the 6 is already done also. So we have the 2 5s looking in here, putting a 5 in one of these two. So that's all the buddies we're going to find. I'm going to think about the 4 digits in this box. We need a 1, 2, 4, and 7. So I'm just going to fill that out and we'll clean it up. 1, 2, 4, 7. So these can't be the 2 because of that 2. These can't be the 1, and then this 4 looks up. Now this can be all of 1, 2, 4, 7, so I'm actually not going to mark that one up. But that seems helpful. This row, similarly, we need the 1, 4, 5, and 7. All I see, okay, this can't be 4 or 5. Okay, I'm just going to, again, we'll just mark them up. 1, 4, 5, 7. So that's not 5, that's not 4 or 5, that's not 4, and that's not 7. All right. I always like to think about it first, just so that I have the expectation of what's going to be limited. So, because once you pencil it up, now you're having to find patterns within your pencil marks, and so you might as well just think about it first. Okay. What else? What's going on here? 4 looking up. Is there like? We know the 2's limited. I don't see anything else to do here right now, so I think I am going to just move on. Okay, let's move on to this band here. So we'll start with this 2 and 7. They do have no buddies at all. 1, 4, and 8. Just the 4 has a buddy, so we can mark 4s here. A lot of options for geometry here. We have this 7, 2. So this 8 looks up, this 8 looks in. Unfortunately, the 5 could join it here, but there is no 5 over here. So we get the 8 in one of these two. That points in along with this 8, putting an 8 here. Okay. Anything else looking through here? I don't think so. And then in the reverse of 7 and 2, lots of places to put. 1, 4, and 8. We care about this row, this column. Oh, okay. So this column has what we call the New York Times trick, right? Or what I would more generally call geometry, where we're looking at the shape of the givens. If we just completely ignore, I can't actually blank out the digits, but if we completely ignore the digits, just look at the black cells here, right? You can see you've got 3 here and you've got 3 here. This is the kind of geometry you're looking for. And then you need to pay attention to whether there's any repeated givens, right? There are not repeated givens. We have 1, 3, 4, 5, 8, 9. There are 6 unique ones. So in that case, we can ask, where do 1, 4, and 8 go in this column? And the answer is there are only 3 places left for them. So that's where they have to go. We need 3 cells for 1, 4, 8. These are the 3 cells. And actually, we do see that these 2 cells, C and 8. So the 8 gets placed here, the only place for 8 in the column. And we're left with a 1, 4 pair. Well, if this has to be a 1 or 4, it's certainly not a 2, so that lets us place the 2 here. Additionally, because this is only 1 or 4, we know the 7 is limited, so the 7's in one of those two. That points in along with this 7, putting a 7 in one of these two, so this can't be 7, leaving a 7 for one of these two. Nice. I don't think we can do more with that, but that's nice. We can then do the corollary here. So the 3, 5, and 9 look into this box. And we can actually see that we actually have a bunch of 3s looking in the box. Let's take a 3 first. And then the 5 and 9 look down through here, putting a 5, 9 pair here. And that leaves us with a triple. We need the 2, 6, and 7, it looks like. And this can't be 2 or 7. So that's our 6. And these are not 6. All right, that's a very good start. We got to figure out what to do with all this information. Did we limit this band anymore? We do have 9s. We had got this 2. Okay, the 2s and 9s are basically are done for the band. Not basically, they are done for the band. Is there anything else? Like maybe I limited the 7s out of some places. 7 can't be here. Yeah, I'm not sure what I can do with that right now. Should I keep looking at this band? Obviously, I should keep looking at this band. I meant, should I get back to it? We've got just 3 digits left in this row. We need a 1, 5, and 8. And this 5, 8 looks in here. So this can't be the 5 or 8, so it is a naked single 1. We're left with a 5, 8 pair here. So what are the remaining 4 digits here? Right, we need the 1, the 2, the 6, and the 7. 1, 2, 6, 7. Well, this cell here sees 1, 6, and 7, so that's a 2. That's 7 and 2. Okay, so the 1, 7 see this cell. So the 1, 7 go down here, and this is the 6. All right, so now, I guess this one looked up a while ago. But now that we have 3 cells, 3 digits left for the row, we have 1, 2, we need 3, 5, and 9. So the 5, actually, if you look, can only be here in that row. And then down here we have the 4 and the 8, and it looks like 6 is the other digit. Okay, that doesn't clean up. All right. This band is obviously, there's nothing else to find. We just have horizontal pairs and triples left within boxes. All right, this band here, the 7 has nobody. We do have 2 8s. It's an 8 somewhere up here. Nothing else there. Anything looking through this 3 8s? We have 5, 7, and 8. Or I guess the 8 doesn't matter. We have 5 and 7 looking through here. Wow, we don't have a single 5 or 7 up here, so we can't actually do anything. Okay. I don't think the 7 does anything. Nah. What about this 4, 5, 8? So we need an 8 in this column. Let's see, we need 4 and 8. Ah, here we go. So we have another one of these geometry things, right? We need 4 and 8 in this column. And they can't go here because of this 4, 8. And they can't go here because of this 4, 8. So the result is, actually we had this right from the start, but it's kind of a hard spot. There's only 2 places for 4, 8 in this column. So this is the other 4, 8. All right. Let's see, what can I do with that? Well, I guess this is a triple. So, oopsie. The rest of this triple is 1, 3, 9, it looks like. Top one's not 3. So the 1 is limited to these 2. That's going to claim. Oh, this one here. Yeah, okay. Yeah, we get 1s here. Sorry, I got confused. But yeah, just we can pencil 1s in one of those 2. So this cell looks pretty limited. In fact, we should think about what was removed from this cell. So the 1 was removed. We got that marked here. The 3 was removed. Okay, so 3 is in one of these 2 now. That points in here along with this 3, putting a 3 in one of these 2. That forms a hidden 3-7 pair. Very nice. Because we have these 2 overlapping 3-7 corner marks, you can immediately see that because they're overlapping like that, it is a 3-7 pair. Because 3 is limited to these 2 cells, and 7 is limited to these 2 cells. So 1 gets 1, 1 gets the other. Nothing else can go in there. So this is down to 1, 4, 8 for the row. Let's see, this can't be 5 or 4. So what can this be? This can be 1, it can't be 2, it could be 3, it can't be 4, 5, 6, can't be 7. Could be 8. Okay, so 1, 3, 8. Not as interesting as I hoped. Oh, but I have a 3-7 pair here, so it's not 3. Right, the 3's point in. So 1, 8. Okay. Yeah, 1, 4, 5, 8. So the 8's one of these 2. Oh, the 4 is here. Okay. Can I do anything with that? Not. Oh, maybe I can. Yeah, 4 ends up in one of these 2. I feel like there's a lot that I want to kind of wind back and look at. That was just from looking at how the 3 was removed from here, right? So the 7 was not removed. No. The 8 was removed. No, the 8 was not removed. It can be 8. Okay, that's it then. All right, let's take a step back. What did we just get? I found this 4, 8 there. We got this 1 claiming. We took care of that. Okay. Is there anything else to do to follow up on what we just got here? Because I feel like it's a lot. 1, 5, 8 triple. That seems nice. Look at this. So this is what we call a naked triple. And I think this is the most confusing of the techniques that you need to learn. Most confusing for new solvers, because you get used to this sort of pattern matching approach rather than logical approach to understanding techniques. If you're it's okay to use pattern matching as long as your patterns are correct, but you might miss something if it doesn't match one of your patterns. But if you understand the logic, it makes it much easier to understand why you're doing the eliminations you're doing. I think a lot of new Sudoku players will just like memorize such and such technique type 5 or whatever, like use some random name for it and just go, well, this is the pattern for such and such technique type 5, so I'm going to apply it. But instead, I much prefer to understand the technique that I'm actually doing here. And by understanding what you're doing, you can get a lot out of it, and you can recognize it when it doesn't exactly match the pattern you're looking for. So I think when people look for naked triples, they're looking for this being 158, they're looking for this being 158, and they're looking for this being 158. And I often get the question, how could this be a 158 triple when this can't be 1, this can't be 5, and this can't be 8? My first thing that I want to impress upon you is that it is impossible for a technique to eliminate fewer digits just because within that technique you've made some eliminations, right? We could easily pretend, you can always pretend that a cell can be more values than it actually can be, and apply logic based on that, right? If it helps me to pretend this can be 8, pretend this can be 5, and pretend this can be 1, it's perfectly fine to do so. Like, what if I hadn't found this 1 yet, right? Then it would be 158. Right. And if you can see the technique of it with it being 158, but now I've placed this 1 and suddenly you don't see the technique anymore, that's because you don't understand the technique. It's not because it's not there. It can only become more powerful. So let me talk about this. This is a naked triple. This cell we have determined through whatever logic we've done so far in the puzzle. We've determined this cell can only be a 1 or a 5. In our solution, we will be placing a 1 or a 5 in here. Similarly, this cell will only be 1, 8, and this cell will only be 5, 8. So the first question to ask is, can I repeat any digits in the green cells? I cannot repeat any digits in the green cells because they are all in the same column. Easy, check. All right. Because I can't repeat any digits in these cells, how many digits do I need to put in the cells? Hopefully these are extremely easy questions to answer because honestly, this technique isn't actually that hard to understand once you approach it correctly. So no, I need 3 digits for 3 cells. 3 cells in a Sudoku, each cell will have 1 digit. So I need 3 digits, and those needs to be 3 distinct digits because I can't repeat any in those cells. So I'm going to have 3 distinct digits in those cells. Okay, final question. What digits do I have available to put in those cells? Well, looks like it's only 1s, 5s, and 8s. Can you name any digit besides 1, 5, and 8 that is available in any of the green cells? I'll wait. 1, can't put a 2, can't put a 3, can't put, I'm not going to go through them all, but it's 1, 5, and 8, right? So therefore, because I need 3 digits to put in those cells, and the only 3 digits I can put in those cells is 1, 5, and 8, those are the digits that are going to go in those cells. So if I'm putting 1, 5, and 8 in the green cells, the rest of the column can't be 1, 5, or 8 because I'm already putting the 1, 5, 8 in the green. I can't put them also outside of the green. And it only, in this case, only affects the column because these green cells share a column, but they don't share a box, they don't share a row. So I could put, for example, a 5 here. That would be fine because that still allows me to put a 5 in the green down here. So anything that sees all of the green cells, every single one of them, can't be 1, 5, 8. So the conclusion here is that, for example, this is a 7 and this is not an 8. So that's the first piece of logic. But also, now that you understand this, you might not be able to notice, hey, wait a minute, but where is the 1 going to end up in my green cells? It's not going to be here. The 1's going to end up here. I'll make those purple. The 1's going to be in the purple cells. Well, if the 1 is in the purple cells, then any cell that sees both purple cells can't be 1. And so you could have applied the 1, 5, 8 triple and then later notice the 1's claim in this box. That's fine. You can do the naked triple and then you can do claiming. But if you understand the technique, then it's very easy to see that because 1 is going to end up in one of these 2 cells, it's not going to be here. So we can eliminate those as well. So I wanted to point that out. Hopefully that's helpful for you. And so this ends up as 7 because it can't be 1, and that's a 1. This is 3 and 7. And let's remove this 8 here. So that means there's a triple remaining for this column. So we have the 1. We need a 2. We need a 6, and we need a 9. All right, so this is a 2, 6, 9 triple because 1, 5, 8 was removed. Alrighty, so sorry for the long explanation for people who already understood that, but I feel like I get questions a lot, especially for that form of triple. And I think it's nice to point out that you can do additional things with it if you pay attention. Sometimes. Sometimes you can, sometimes you can't. Okay, so we just got some nice stuff out of that. What do we do with that nice stuff is the question. Let's, so I got this 1, 5, 8. Okay, all right. I don't know that there's much more to do with that right now. What was I scanning? I just spent so long on that explanation. I don't remember what I was scanning, but That's another thing. If you can keep your momentum up on the puzzle, it helps with your short-term memory. I think I was still following. Was I still following up on this 4-8 I found? I think I was. So I think what I'm going to do now, maybe I should pay attention to what this 269 did. So we removed 158 from these cells. That already restricted 8. Did it restrict 1 or 5? You know, I don't think it did. Oh, it did restrict 1. Okay, 1's in one of these two. Aha, and so now we have lined up 1s. Notice I have them marked here and I have them marked here. Whenever I mark 2 in a box, right, I want to look to the other boxes that are perpendicular to it, right? In this case, because these are vertical, I want to look horizontally and see how the row, basically see if it lines up in other boxes. And so really what we found here is we found that this row needs a 1, and it's not in this box, it's not in this box. So the 1 ends up here, and this one helps as well, putting a 1 in one of these two. So that's going to claim the box. So these, importantly, these two are not 1. That's the important conclusion we got from that. All right. Can we follow up on these not being 1? Probably. So they're not 1. They could be 2. They're not 3, 4. They could be 5. They're not 6. They could be 7. They're not 8. So they can still be 2, 5, 7, 9, which is unfortunate. All right. I'm just going to have to remember that these aren't 1. I don't want that marked right now. I think there's probably lower hanging fruit to do. So I think at this point, I'm going to move on to the stacks here and see what we can find. So we already kind of took care of the 4-8, didn't we? We got the 5s are done. So we've got 1, 2, and 7. All right, we do have 2 2s looking down here. So we have a 2 in one of these two. Also, this column is down to, it's down to 5. 1, 2, 3, 4, 5. I don't know if I want to do that. We already found this 1, 3, 9 and this 4, 8. Okay. I don't know that there's more to do with this stack right now. Let's look at this stack. I feel like I have, but let's just take a look again. All right, so the 3s and the 8s we have taken care of. I'll go through the digits. 1. I want 1, 3, 4, and 8. I think are those the interesting ones? No, maybe 2, 6, 7, and 5, 9. Okay, yeah. So this 2 looks down. There's a 2 over here. The 6 is here. The 8s, no. 5s, no. Okay, I think that's all I'm getting out of that. Let's actually move on. And I feel like I did this stack as well, but actually let's pencil this column here. So we know we need the 4. Let's see, we need 3 and 4. So 3 is actually limited to these two. So this is a hidden 3-4 pair, right? Because the 3-4 looks in here. And we have 3, 4, and 3, and then the pointing 4s. Nice. Anyway, 3, 4 ends up here. Hidden pair. This is 5, 8 then. What can I do with that? So this is 1, 5, 8. That's not an 8. Okay. 1, 4, 5, 8. I don't really see what to do with this. I feel like this is going to collapse soon, but I need to find the right thing to collapse it. All right. So what did I miss? Let's see. Can I follow up on anything here? So we removed 1, 5, 8 from these. The 1 and the 5 might be interesting for some reason. I guess they already couldn't have been 1. No, I'm not seeing anything with that. Okay, so what are we looking for here? Maybe these cells are limited. So we need a 1, we have the 2, we need a 3, we need a 4, we need a 8. 3, 4 only. What are we looking for here? How about this column? I know it's down to 5, but I gotta start somewhere. We know that these aren't 1 because the 1's pointing down, so they're not 2. I think they could be 3. Can't be 4, 5. They could be 6. This one can be 7. They can't be 8. They can't be 9. Okay, 3, 6, and 3, 6, 7. Can I do anything with that? Not that I'm seeing. Wow, this is taking a bit. Although I did spend a long time explaining the triple, so and that then I lost momentum from that. But I feel like that was a nice teaching opportunity. All right, so here, this column, we need 1, 2, 5, and 9. No, I missed something. 1, 2, 5, 7, 9. This isn't 5 or 7, so this is 1, 2, 9. I'm not really seeing anything with that. This column, we need 4, 5, 6, 7, 9. Again, not 5, 7. So 4, 6, 9. 5, 6, 7, 9. What am I missing? 3, 4, 5, 1, 5, 8. Oh, it's this 4, 8 pair here. Yeah, 1 in this row can only go here. So that gives us 1, 7, and 4. It was that easy, but I wasn't paying attention. That's 3. We get 9 and 3 here. This can't be 3 anymore. So that does put the 3 down here somewhere. Okay, we get the 4 here. This is 3 and 4. We get our 6 and our 3 that we just marked. We get our 8 and our 1. That's 7, 4, and 8. We get our 4 and 6. That's not a 3. We get our 9 here. That's 2. All right, we get our 1 here. 5 and 9. This resolves 8, 4, 5, 1. That's 5 and 8. We get our 5, 1, and 8. 9 and 1. Getting there. 6 and 9. That's a 6. This cell, I have to scan it. That's a 7. Here I need 2 and 5. So that's 2 and 5. We need the 2 and the 7, and we're done. All right. That last little spot of just, it is super easy, but just, I didn't notice we created a 4, 8 pair up here, which, my bad. My focus was so much on the bottom of the grid that I just wasn't paying attention to that. So I apologize if you were yelling about that, but I feel like I found some really nice stuff in this puzzle and some good teaching moments. So at least we got that. Hope you enjoyed this. If you did, then why not leave a like, subscribe, and a kind comment below.